right, so 18.1, homeostasis preserved through intracellular communication. So the mechanisms of communication for the endocrine system, you definitely need to know that. There's a list right here. These are the ones that you need to understand the process and how it works, which is direct paracrine, autocrine, endocrine, and synaptic communications. Okay. So this is a pretty good table to help you kind of organize it, but then you make sure you go back and look at the rest of the sections. So this is a comparison of the endocrine and nervous communication. You understand that? All right, so 18.2, the endocrine system regulates physiological process by releasing blood-borne hormones. Definitely. Overview of the endocrine organs and tissues. Endocrine cells. Okay, so you definitely need to know the organs associated with the endocrine system. You need to understand the target tissues from hypothalamus to the pituitary or the hypophysis, right? All the way down to each and individual endocrine organ. And then, of course, the hormones associated with each of those individual organs and the functions of those endocrine hormones down at the organ. Okay? So what they affect, the effect of them. So this is a helpful chart. Again, remember I asked you to make your own chart. That was probably the best way to learn all of these endocrine systems, organs, tissues, and actual hormones, is to make your own chart instead of trying to memorize something that they've already spoon-fed you. So the struggle is how you learn this. Okay, so the struggle of making it your own is how it actually really sticks in your brain, okay? Okay, so prostaglandins and leukotrienes and all that fun stuff. Make sure you understand hormones and the amino acid derivatives, peptide hormones and lipid derivatives, and the hormones that are associated with that. Transport and inactivation of hormones. The mechanism of hormone. Is that your ringtone?
Yeah.
That's right. Someone holler at you. It actually sounded like it was right outside the window. All right, receptors. What are receptors? Up and down regulation. You should know these. Hormones and extracellular receptors. Second messenger system. Now, the second messenger system, do you need to know the second messenger system? You need to know what it is, okay? Do I need you to know all of this? Blah, 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 modulin and all this stuff. Now, you didn't need to go into all this right now, okay? But I do need you to know what a second messenger system is. First and second messenger. So what comes in, what does it do, okay? And that'll be sufficient for what we need here, okay? And then something I want you to, as you go through this, you need to be able to ask yourself, why do we have a second messenger system? All right, and generally the answer comes always back to a phospholipid bilayer, right? Which means that we have lipid-soluble stuff can pass through the membrane. Like, for example, things of a steroid in nature or cholesterol is lipid-based, right? Remember we went through the chemistry back in Anatomy 1, and it was lipid-based stuff can pass through that plasma membrane. So steroid hormones like testosterone and estrogen can pass right through that membrane, which makes sense. They affect the nucleus. So this is why we have a second messenger, because things can't pass through. Right? So we have to stimulate inside the cell, and that's the process. So if you understand that, and that makes sense to you, then adding this or figuring out what first and second messenger are. Which then you can kind of jump through most of this, look at it, kind of read through it. You can kind of skip over all the little details of calcium and calmodulin and all that stuff and just kind of run through this, okay? this is hormones and intracellular receptors. Okay, intracellular gene activation. Make sure you read this one. This is kind of talking about that passing through. Controls of hormonal secretion. We have humoral, hormonal, and neural stimuli. You should know all three of those for sure. Of course, this is talking about anterior lobe, anatomy of the hypothalamus and the pituitary gland. So this goes through the process. What is it? Where is it? Okay, so the regulatory hormones. Remember, we have the hypothalamus, which secretes regulatory hormones, and what secretes the tropic hormones.
The anterior lobe of the pituitary gland.
Which is also known as the adrenal hypophysis,
yeah.
right? Okay, so that is the tropic hormones, which just means turns on, and it turns on those target organs that you should know where they're at already, okay? All right, so then of course, this also shows you, so we have two nuclei, which will come to in a different picture, but we have what? Supraoptic, remember this is the optic chiasm, and I showed you guys this in the brain, in the human brain. That's where that crosses. So right above that, inside the brain, there's the supraoptic nuclei and the paraventricular nuclei, right?
Mm-hmm.
And each one of those it secretes what?
ADH and oxytocin.
ADH and oxytocin, which then are transported to the what? To the what? The neurohypophysis, right, or the posterior pituitary, okay? You guys remember how that gets down there? How does it get transported? Kind of shows you there. See the green stuff, green lines?
Nerve.
That's why they call it the neurohypophysis, because it comes down the nerves, right? It's called axoplasmic transport, okay? Axoplasmic transport, it's like the bank where you put the thing in the tube and it shoots over to the teller. Just comes down the nerve to where it's going to. So posterior lobe is stored ADH and oxytocin. Okay, then we have the adrenal gland. Of course, you see there the red lines are preganglionic nerves, which just means that's a direct input from up north to the adrenal glands to release those. What are those inside of the adrenal gland, or what? What? What's that? Epinephrine and norepinephrine, which are catecholamines, right?
Catecholamines.
Okay, and that is in the medulla of the adrenal gland. Okay, so make sure you understand that process there.
I think I have the adrenal gland down. The pituitary gland.
So the anterior pituitary has a system known as what? The anterior pituitary receives the regulatory hormones from the hypothalamus through what system?
The
Portal system?
The hypophyseal system, right? So it is a endocrine system, right? So that means that the definition of endocrine is it dumps it directly into fluid, the interstitial fluid or the blood. Okay, so that's what it's doing. The regulatory hormones are dumped directly into the blood, which then come down, then tell the cells down here to start producing whatever hormone they're going to from that anterior pituitary, which then are, of course, the tropic hormones. And this, of course, shows you your supraoptic paraventricular. Okay, so the regulatory hormones, remember, the RH does not stand for regulatory hormones, it is releasing hormone. Okay, releasing hormone. So we have, so TRH is not thyroid regulatory hormone, it is thyroid releasing hormone. Okay, so make sure you understand that. Of course, that's a distractor on the test, right? Something to throw you off a little bit, so it makes you know it. So look for distractors, look for things that are not right when you're going through the test. Make sure you read all of your answers on the test before you jump on it. Okay, it's not a race to see how fast you can finish the test. Okay? So you guys that finish the test in 15 minutes, maybe slow down a little bit, 20. Okay. All right. So again, as I said before, make sure you make your own charts for the regulatory hormones and or the tropic hormones and tissue associated with each of those. Don't fight it, go do it, because you guys are gonna have to have it again when we have number one, final, number two, the practical, right? So I suggest that you just spend the time that it takes to learn the material. So you have not only this test coming up, so you have 3 different tests that are associated with just endocrine stuff, so don't fight it, just go learn. Okay? I know how you guys are. All right, so this is going through each of those hormones and the target tissue, the cells. Definitely need to know all that. Summary of the hormones of the pituitary gland. Here they are. Summary. Make sure you go through this. It will help cement the hormones and their target tissue. Again, I suggested that you not use this table, but you utilize it to make your own. This is going to the anatomy of the thyroid gland. Of course, you need to know how it works. You need to know how to make the thyroid hormones. No, don't even know how to make it. You need to know how to use iodine to produce it. Okay. We need to know about thyroglobulin, which is in the colloid, right? The colloid is actually the precursor to thyroglobulin, and it contains T3 and T4. Okay. So that's. Iodine, 4 functions of the thyroid hormone. Thyroid's a pretty big deal. We see a lot. And of course, we have calcitonin from what? The C cells, which are also called what?
Clear cells.
Which are what type of cells in the thyroid? They are para-follicular. Remember, they're the follicle, the epithelium, and the C cells are para next to follicular.
I feel like he definitely C cells.
Okay, so 4 parathyroid glands. All right, so make sure you understand the process between rankle. Okay, rankle. Okay, everyone remember what a rankle is? Okay, so we have osteoblast, osteoclast, right? So there's the whole process for doing the rankle. What's it for? Osteoblastic activity, of course, that builds cells, and osteoclastic activity, right? And PTH, did you understand that?
Yeah.
Okay, so follicular epithelium, C cells, and then of course that's in the thyroid gland, and the parathyroid glands, the PTH right here, add it to your list, of course. So the paradrenal glands secrete several hormones that affect your electrolyte balance and stress response. Adrenal gland, suprarenal, right? Suprarenal just means above the kidney. Here they are. We have the cortex and the medulla. Okay, and then of course the zones for the cortex, glomerulosa, right? Fasciculata reticularis, and then the medulla. So corticosteroids, mineralocorticoids are for the zona glomerulosa, aldosterone, which we'll get into, aldosterone, zona fasciculata, which is the glucocorticoids, as well as the cortisol, cortisterone, cortisone. The effects of the glucocorticoids, anti-inflammatory, androgens, zona reticularis, and then of course our catecholamines of the adrenal medulla, the epinephrine and norepinephrine. Pineal pineal gland, location, obviously. Pineal gland, of course, all of them are location. What does it secrete? Melatonin. What is melatonin? What does it do? Got some other issues there, some other things there that you should probably look into. Pancreas, of course, exocrine and endocrine. The exocrine means it secretes it into the what?
Ducts.
What?
Ducts. Into the ducts.
Exocrine is duct. Duct with a T, not a K. Not a CK. So duct. Okay. And then of course the endocrine system, those cells that secrete that insulin and glucagon are in this structure, which is called a pancreatic islet, also known as a what? Starts with an L, sounds like Langerhans. Islets of Langerhans, okay? That is where we'll find the secretion of these guys, the endocrine stuff. So remember, this is showing you right here is the cluster of the endocrine cells here, and then of course this is the pancreatic islets, the islets of Langerhans, which then secrete those other things, okay? When we do the blood smears, we'll have to go through and look at some of the endocrine slides as well. So we need to make sure that if you remind me in lab next week that we look at some islets. So, okay. There's your functions: alpha, beta, delta, pancreatic polypeptide. So those 4 different guys there. Of course, goes through insulin and glucagon. Here's your table, which helps cement the reading up there. Make sure you read diabetes mellitus. And of course, many organs have secondary endocrine functions: intestines, kidneys, heart, thymus, gonads, adipose tissue. So these are some representative hormones produced by organs and other systems. Again, go through this, make sure that you understand different secondary systems for different organs. And then of course this goes through it, calcitriol, erythropoietin, we talked about a little bit, right? EPO, hypoxia, right? Low oxygen levels. Renin, I'm not gonna really, right now we don't have to go through the angiotensin-aldosterone system, the RAS system, RAS. So this, you don't have to get into angiotensin 1, angiotensin 2, ACE inhibitors, all that stuff. Natriuretic peptide from the heart, thymus, thymosin, the gonads, and of course here's your testes and ovaries and those hormones associated. Again, this all comes from that chart that has the fan of all the hormones going down to these organs, okay? So you need to, like I said, you can help add to that chart, your own chart, this information. Clinical implications of endocrine malfunctions. This is helpful for you to help cement what those particular hormones do as you go through. Overproduction tissue, principal signs and symptoms, things like that. Not necessarily the disease associated with it, all right, but as far as what it does, it will really help you with cementing the functions of those hormones. Adipose tissue and leptin. So try and figure out what the leptin and ghrelin, the difference. Okay, leptin and ghrelin. It's in your reading, so if you'll just. Ghrelin with a G, GH.
I don't see it anywhere.
Ghrelin comes from the stomach. So roles of hormones and growth, make sure you just go through this so that you can, again, that'll help you kind of fixate what these hormones do. Understand what gas is, okay? Here's the alarm resistance and exhaustive phase. Of course, effects of hormones on behavior, aging, and hormone production. And then integration, again, just to help fixate what these hormones do. And that should finish it up. Review questions, make sure you do them all partially. And then we'll check to see that you've done them the day of the test. So we'll have to do chapter 18 and 19 for your extra credits though, right? Everyone remember that? Right, so now that people have stopped walking in late, remember what happens if you come in late for the test, you will not take the test. So don't be late. Don't be late for the test. You'll be sad, okay? You need a Scantron, number 2 pencil, right? Okay, so next chapter is blood. Of course, there's almost everything in the blood you need to know, with the exception of the clotting factor. Okay, so what are the functions of the blood, the characteristics of the blood, for sure. This is a wonderful spotlight to help you get a lion's share of this material. So the composition of the whole blood, remember whole blood is everything. The formed elements are the red blood cell, white blood cell, and the platelets, right?
Mm-hmm.
Okay. All right. Go through this, go through all the proteins in the plasma, other solutes, make sure you go through these guys. Fluid connective tissue, what is it? The hematocrit, okay? Okay, and this course goes through this next in a little bit more detail, which we probably should introduce about it. Plasma proteins, formed elements, hemopoiesis, the production of, right? So anything that's poiesis. What are red blood cells? They're also called erythrocytes, right? What's their function? What do they do? What's the hematocrit? Here it is, RBC test and related terminology. So these tests are important. You need to know these tests. MCH, MCV, HB or HGB. Red blood cell count, reticulocyte count. What is a reticulocyte? Remember? So at day 4, what happens to red blood cells?
They lose the nucleus.
They become anucleate, right? Okay, so then day 7, they are ejected. So between that, they become, once they lose the nucleus, they become reticulocytes. Okay.
So we have 4 to 7.
All right, so the red blood cell is shaped in a what? Biconcave disc, okay? What's the reason for the biconcave disc? All right, see those things, the stacking, surface area, flexibility to squeeze through very narrow areas, okay? So there it is. Hemoglobin structure. Remember this is hemoglobin. Or what's the most important thing about proteins?
The shape.
The shape. And here's what type of shape are we looking at? This heme, or this globular. Globular shape is called what? Quaternary, right? Primary, secondary, tertiary, and then folds in on itself called quaternary. And that's what it's doing, is folding in on itself. Okay, so deoxyhemoglobin and oxyhemoglobin, it either has oxygen or it doesn't. Carbenohemoglobin, anemia, these are all kind of definition things right there. So the stages of the red blood cell maturation, there's that injection at day 4, and then it becomes anucleate, and then it's a reticulocyte. PTO, there's the hypoxia again. It talks about the blood doping. Hemoglobin recycling, you have to know how the process goes. No, you don't really have to go through that, other than suffice to say, we are recirculating or recycling the iron, we're recycling that hemoglobin products, the red blood cell products. Hemoglobinuria and hematuria, the difference of the two. Jaundice. Transferritin, hemocedrin, and ferritin, those are all kind of definitions. What are they? Next is we have the ABO and RH blood groups. So ABO groups. Remember what is an antigen?
Sorry.
What is an antigen?
On the outside.
That's on the cell. Okay, so remember that everything has, every cell has antigens on its surface, and if it's not ours, our body will attack it, right? All right, so in this case, we have A antigens and B antigens, right, on the surface of the blood to describe what blood type that is. So A antigens have A, or A blood type has A antigens, B has B. What does AB have?
None. Oh, wait, no.
For antigens. What does AB blood have for antigens?
It doesn't.
Both.
Say that again?
They have A and B antigens, but they have no antibodies.
Yeah, the lady who said no. Yes, AB blood has both the A and B antigens, but no antibodies.
That's right.
Okay, no antibodies. Okay. So if you have type A blood, then you'll have what type of antibody?
B.
If you have type B blood, then you'll have a type A antigen. Okay, so these are showing you your antibodies, and then they show it agglutinating, which is clumping, right? And then of course we have hemolysis or hemolysis where it breaks it down. Okay, so you should be able to go through the blood types, cross-reaction, cross-matching. How do we do it? Why do we do it? What's the purpose of it? How can we make sure that for real, that there's not going to be some type of reaction? Remember, there's a bunch, you can have A negative, get A negative blood from somebody else and still have a reaction. Okay, although it's not a lot. Just remember, there's more than 3 different antigens on markers. There's 48 different types of antigens that we know of on the surface of cells, so you can still have a reaction to antibodies there. So what's the best way to do that? To actually test it? You take the blood you're going to use, right? Take the blood you're giving it to, and make something, see what happens. Right, that would be the best way. Or, of course, the testing, there's still some testing ways that actually helps with DNA. Okay, you don't have to memorize. I'm not asking you to know different blood groups and ethnicities. That's not important. You just kind of recognize that each ethnic group has a little bit different. It's kind of interesting. Native, South American, 100% O. So when you can look at this stuff and someone says, "Oh, I'm native South American," and you check their blood type and they have A, you're like, okay, no. You're not, but okay. So, but that's the point, is you can look at this stuff and, or look, all the 100% and there's a Reese positive, and they show up as a Reese negative with a blood type. You're not one of those, right? Okay, so agglutinogens, agglutinins, agglutination. Sensitize, of course, that's a Reese factor. Make sure you understand the Reese. Transfusions, cross reactions, compatibility testing, blood typing. How many guys did the Nobel Prize blood typing game at home and showed your parents or brothers, sisters, family members, and got it to scream really loud? Oh, what's right? Alright, so this, by the way, this is the blood typing game right here. Okay. Universal donors, universal recipients. understand the process, why it's the second pregnancy that causes the problem. So white blood cells, you need to know what is a white blood cell, where do we find it, the different types of cells. This is the pneumonic, right? Never let my engine blow, 60-30, 830, yes?
Mhm.
So that's percentage of white blood cells in your blood. You need to know the granulocytes, which is Ben, right? Ben, granulocytes. What are the granules? Of these white blood cells, which ones have amoeboid movement? Which one of these have amoeboid movement? All of them. All of them have amoeboid, okay? Degranulation, of course, that's getting rid of your granules. Eosinophils, basophils, endothelium. You guys gotta read these sections so that you understand the process of what's happening with them. What's the macrophage? Is derived from what, which one of these?
Monocyte.
From monocytes, right? So the macrophage, and then we have microphages, which are what?
Neutrophils.
Neutrophils. Okay, so neutrophils are microphages. Okay, so lymphocytes, we had two different types of tissue type. We have myeloid and lymphoid tissue, right? So the myeloid tissue is all the other cells, and the lymphoid tissue is what makes the lymphocytes. Then lymphocytes gets broken down into different types of cells. It gets down to the T cells, the B cells, and the natural killer cells. Okay, the T cells, the B cells, and natural killer cells. You need to know what those three different cells do and why they're there. Differential. What's a differential? What does a differential count in your blood tests? What's that? That's exactly right. You're counting the different white blood cells. So you actually look under the microscope and you count 100 different white blood cells and you get a percentage of each of the different white blood cells. Chances are you probably will never see a basophil unless there's some condition that that person has that causes basophils to get reproduced quite a bit. Okay, so because they're so low, right? So the lion's share, what you're going to see is neutrophils generally. Never let my engine blow, right? 60-30, 830. Okay. So these right here, we see these are, remember, the red blood cells, these white blood cells, platelets are all part of the what? The formed elements, right? Leukopoiesis, production is called leuko, is white, creation, poiesis. Right, now here's that myeloid, stem myeloid cells and lymphoid cells. EPO coming in effect, what is EPO? Erythropoietin from the, where does EPO come from?
The kidneys?
Where does
The
EPO
neutrophil?
come from? Erythropoietin. What'd you say? Kidney.
Kidney.
So EPO does what? It is increased in stimulation and production with the condition of,
Hypoxia.
you got it,
Mhm.
hypoxia, reduced oxygen levels, right? Okay. Then of course that stimulates the production of red blood cells, which do what?
Carry oxygen.
Carry oxygen. Okay. All right. Okay. Do you have to go through and memorize this whole chart? No, but I would kind of stick to red blood cell production. Megakaryocyte produces the platelets. And then, of course, our lymphoid stem cells or lymphoid tissue creates our lymphocytes for this chart. So lymphocytopoiesis is what? What's a lympho?
It's the
What's
production
cyto?
of lymphocytes.
Cyte is a cell, right? So white cell production, poiesis. Okay, so platelets there for the clotting process. Platelets are also known as what? Thrombocytes. Reduction in thrombocytes is, so lack of clotting factor, or lack of clotting is thrombocytopenia, right? Penia, so lack of thrombocytopenia. So platelet function for sure, platelet production, where do platelets come from? Here's thrombocytopoiesis, not penia, which is reduction. Thrombocytopoiesis is the production of platelets, and they come from megakaryocytes. Okay, megakaryocytes. And they actually don't just like, it's not like one-to-one. Megakaryocytes produce, well, it shows you like thousands of platelets. So. Of course, thrombopoietin will increase the production of protein. Hemostasis, stopping the bleeding, right? It is what type of feedback system?
Positive.
Positive feedback system, and all feedback systems require three things. They all have three things in common, right? They have a receptor, a control center, and an effector, right? What? Share it. No? Okay. Okay, so bleeding is a positive feedback system, which does what?
Exaggerates the condition.
Exaggerates the condition, right? We want it to stop. We have to have hemostasis. Must occur. Okay, exaggerates it until it stops. So this is the process. This is the vascular phase, platelet phase, and coagulation phase. Okay, that's the phases of stopping it. You need to know the phases. What you don't have to know is the clotting factors. I don't need you to learn the clotting cascade. Okay? Suffice it to say, you can see that we have lots of different processes that have to occur to go through the clotting cascade. Know that there are the pathways. Know that there are the pathways, the extrinsic, intrinsic, and common pathway. Okay? Okay, so calcium, vitamin K, and blood clotting. Make sure you go through this section here, the vitamin K. Clot retraction and fibrinolysis. What are those? And of course, that should finish the chapter. Yep. Okay, so you have review questions for this chapter as well. All. Okay. So there's a lot of material for this test. Okay, but we've had, what, 3 weeks now? This is the 3rd week to start studying for this stuff. So you should not be, have not had seen this ever. If you haven't even started looking at this, I can't help you. Okay, but so make sure that you get it tuned up and looking good for test next Tuesday. All right, anyone have any questions? Make sure you're not late for the test. Bring a Scantron. Okay, otherwise I will see you. Have a good weekend. Study, study, study.
You said that epinephrine and norepinephrine, they're both sympathetic neurotransmitters?